The next one we're going to do is sine of x. Now, you probably remember, or maybe you don't remember exactly what it is, but do you remember sine, cosine, and tangent from geometry?
Yeah.
Okay, so when we get a little further in math, we start using them for more than just right triangles, and we use them for some other things as a function. And so right now, we're just going to talk, you don't have to know why right now or how. Right now, I just want you to know what it looks like when we graph it, okay? And that is it right now. So when we graph it, and this is going to look weird, what we get is a curve. Let me get on another page that doesn't have a heading. That continues on and on and on and on. You'll want to take your y-axis up to 1 and down to -1. And your units on your x-axis, I'm so hesitant to even say this, are half pies.
What?
So, pi over 2, pi, 3 pi over 2, and 2 pi.
So we don't have to graph this.
But literally just like I'm doing right here.
Okay, how would you do it on the calculator?
And why is it?
You'd have to have your calculator set to radians. No, it's really not. All right. It's okay. I told you. All right. Here's what's going to happen. The sine and the cosine function look very, very similar to each other. When we do our table of values, the values that we are going to use are the values that we have on here. Okay? These are going to be your hardest two. I don't even think I put tangent on here. I think we're just going to do sine and cosine. Let me see. Yeah, sine and cosine. The hardest part for you is probably going to be remembering the table to put the values in here. Okay? So we're going to use exact ones. Let's go -pi, -pi over 2, 0, pi over 2, and pi. Now, the x values are super bleh, but the y values are not so bad. 0, 0 is a point on this graph. Yeah, tell me when you caught up with me. Oh, I forgot to record. But at -pi over 2, it's going to be -1. I'm just telling you. I'm just telling you right now. You could put this on the on the calculator.
So will we ever be able to actually
Yes. Right now, our focus is going to be transforming the graph and making it look different from the parent function, but we will get into when we get into unit circle, we'll get into the sine, cosine, tangent functions. It's going to be such fun, Avery. It's such fun. Not yet. All right. The next, at the pi's, it bounces back to 0. And this is the pattern it's going to repeat as we go. So if you look at what it's doing, okay, start over here. 0, -1, 0, 1. 0, what do you think this one's going to be? -1, what is 2 pi going to be? 0. It's a squiggly line. You're exactly right. Okay, so this one comes back up and comes back down. So here's what it looks like. Have y'all ever heard of well, probably not, never mind. A sine curve? Or a sine wave? I said, yeah. All right, so it looks like a wave going. That's what the sine graph looks like. Okay? I know. I told you today's were not going to be fun. Looking at this, what is the domain?
Yeah.
Left or right? Absolutely. Negative infinity to infinity. Is this a function?
Nope. -1.
It is. Why is it a function? Well, how do we tell if something's a function? What do we do? Y'all can do this.
Vertical line.
Vertical line test. That was a great guess, though. Does it pass the vertical line test?
Yes.
Yes. It'll never hit a vertical line more than one time. So it is a function. The range, Sally already guessed correctly. I don't think she guessed. I think she did. But what's the range? Lowest point to highest point. Look at it. -1 to 1. From the bottom up. The lowest, the graph never goes below this point, and it never goes above this point, right? So it's -1, and I do the bracket because there's actually points there. So -1, come on, Ben, -1 to 1. Is it continuous?
Yeah.
Why? You never have to pick your pencil up.
Can we write that?
Yes, yes, yes. How about the end behavior? Oh. This one's going to be different than anything you have seen before. So you need to write this one down. You're going to have to really look at this. As x approaches positive infinity, what does y do as you move to the right?
-1.
You're exactly right. You are exactly right. That is exactly what it does. We use this big fancy word called oscillates. Have you heard that word before? All right. You know that fan that you have? Your grandma's probably got one in her house that does this number right here. That's called an oscillating fan because it turns from one direction to the other. So we say oscillates, meaning it flips between. So it oscillates between what two values? -1 and +1. Okay, we can't say it goes to a certain value because it doesn't, because as I move further and further and further, it goes -1, +1, -1, +1, -1, +1, and it keeps on going, right? Does that make sense? How about as x approaches negative infinity? Same thing, ditto. Told you this one was a little funky. Symmetry, you're not going to be able to understand this as well algebraically, so let's look at it graphically. Does it show any type of symmetry?
Well, if you fold it, never mind.
Is it odd? Remember, what's the difference in the two? Is it symmetrical about the y-axis? So if you folded it in half at the y-axis, it would be the same. Take your paper and do that and see. This point's going to map here, right? It's not going to be, yeah. Is it odd?
It's odd.
It's just not symmetric.
It's odd.
What does odd mean? Graphically, what does it mean? That's a line of symmetry? Is it?
Oh, to make it odd?
Let's do this. I'm trying to think of how I can get you to see it algebraically. Let's say, we know algebraically is plugging a negative in, right? But we don't really know a lot about sine to know enough to know what happens when we have a negative in there. So let's do this. Let's look at what happens when it's the same value but opposite signs? Zero.
It's even.
You think it's even?
Is it odd?
Do you know that?
Is it neither?
What's the answer?
It's polytypic.
Polytypic.
I think it's gonna be either.
This one's not either.
Is neither?
Well, because this isn't a line of reflection. Because because I'm trying to think of how I can get you to do it algebraically. Because I
Miss
got
McGee,
listed on
straight
your
up,
thing
I said-
algebraically.
It's not, it's not.
I said neither, and you stared at me.
Who did?
Me, I said neither, and Sally said neither,
Oh,
and you stared
I'm
at
sorry.
me
Let's
like,
get a
wow.
challenge.
I'm sorry. Okay, all right, let's just leave it at that, and then I'll take that algebraically part off the test. Let's do cosine.
So symmetry.
Yeah, what was the other one?
The last thing you gave her, you just dropped her.
Oh, I did little ditto marks. It means it's the same. Let's do cosine now. By the way, is this sine function bounded? Where? It's bounded above and below because it has maximums and minimums. Are the maximums and minimums on here relative or absolute? They're relative. Even though they're the same height, you can never have more than one absolute, but it's possible to have no absolutes. So you can't really call it absolute because there's other points that are at the same height, unless it is absolutely the highest point on the graph. And it is absolutely not the highest, it is one of the highest. All right, let's do cosine. Come on. Cosine of X. Very, very, very similar to sine. It's just shifted a little bit. Then my t-chart, set up the same points. Negative pi over 2, 0, pi over 2, and pi. I know, I'm sorry. 1 and negative 1, pi over 2. I'll give y'all a second to... All right, this one's a little bit different. This one at 0, it starts out at 1. Can you guess what it does from here? Guess what the values are at pi over 2 and negative pi over 2. What? It's like the last one, it's just shifted over some. So if... Remember what the other one did? It was a wave, right? This one's going to be a wave too. So if this is the crest of the wave, it's going to come down from here on both sides. And then it will go down and down. And then up and up and up and up. It looks almost identical, doesn't it? What's the difference? It just, if you could literally take that sine graph and just slide it over pi over 2 units, you would have the cosine graph. I'll give you a second to copy all that. What do you think is the domain here? Negative infinity to positive infinity. How about the range? To positive 1. Exactly the same. If you can get one, you should be able to get the other as far as the cosine and sine functions. How about, what else do I need? Is it continuous? Yes. How about the end behavior? As x approaches positive infinity, what does y do? It oscillates. Y oscillates, and it oscillates between what two values, Alex? -1 and +1. The other end, so that's exactly right. As x goes to negative infinity, y oscillates between -1 and 1. Exact same. In behavior, it's the same on both ends. Does that make sense? Yay, I finally feel like we touched on a little pre-cal stuff now.
I don't like it.
I'm sorry. All right, how about symmetry? You should be able to get this one. This one's an obvious symmetry. What is it? Even. Why? You fold it down the y-axis, it's the same on both sides. So it does have even symmetry. Any asymptotes? Yes, no, I don't know. Does it?
No, that's not on there.
I don't know.
All right, thank
Like,
you.
I don't know.
What? Tell me what an asymptote is.
It does for -1, +1.
Oh.
But
what happens at an asymptote? What does the
bounds
graph
the
do? It bounds the graph, but it bounds it how? It bounds it a special way.
It can't
A
go past
certain
it.
below.
It doesn't go past it, and it never touches it, but it keeps getting closer and closer and closer and closer and closer. So does this have an asymptote?
No.
No. It doesn't have any place where it keeps getting closer and closer. This one is bounded, but just because it's bounded does not mean that it has an asymptote. Okay? Asymptote is a way to bound it, but it's not bounded here. Does that make sense? All right. Yes. You won't do that. Don't worry about doing that algebraically. Do it graphically. I'll change that and say explain why. We don't know. We haven't talked enough about sine and cosine for you to know. All right. Yay, nay? Yay, we did 2 already. This is an algebra 2 function. 12.
12 today? No. I thought you said
12 altogether. 6 yesterday, 6 today. This is 9 of 12. We're fixing to do number 9 out of 12. We've only done 2, Shalai.
today we're doing 6.
Yes, we've done 2 so far.
Just want some information right?
This is the I don't know. It's E. I don't know what they call it. The exponential function. All right. Do y'all remember in algebra 2? So this is called the exponential. Think back to algebra 2.
I remember this.
When you did growth and decay, and so growth and decay functions have an asymptote. And don't write this down, but just to give you a reminder, they have an asymptote, and they do this, or they come down and do this. Okay, for growth or decay. Those are 2 different graphs, by the way. That's not the same graph. But just to remind you, so this is a growth graph, and it is going to have an asymptote, and you just have to kind of remember that. All right, so this does have an asymptote. It has a horizontal asymptote at y equals 0. That is the axis. When you pick your points, let's do -1, 0, and 1. I think that should be good enough to pick up the pattern for you. Yes, it's an exponent. Take out your calculator. These are not going to be pretty. I'm going to go ahead and tell you that now. There's a button on your calculator that says E. It should be somewhere around the button that says LN. Okay, mine's right above it. If I do second LN, it'll pull up the E. So the first thing I'm going to do is plug in a -1 there. So what is e to the negative first power? Second ln, so e to the negative first power. Did everybody get that? I want you to see how to use your calculator, because you're definitely not going to want to just memorize these numbers. You're going to want to know how to put it in your calculator. 0.36, I'm going to go 3 places, 0.368. Yeah.
On those calculators, can't you just do second graph and go to the table?
You can. You can. How about 0? E to the 0 power. 1. How about e to the first? 7, 2. All right, so let's graph them. -1. 0.3. You don't have to be really exact here. It's almost to halfway, not quite. 0, 1, and 1, about 2 3/4. Now thinking about what I just reminded you about growth graphs and what they look like, it's going to go up really fast to the right, and this is the direction that it's really going to come down and hug that asymptote. Y'all remember doing these? I'll give you a second to catch up with me before we... What's the domain here? How about the range? 0 to infinity, that's absolutely right. Why did I not put a bracket on the 0? It doesn't touch it, that's the asymptote. Can't touch. How about, is it continuous? Absolutely. In behavior? The right side, you're right, Jenna goes to infinity, and you're right, Alex, the left side goes to actually 0. Because that's that asymptote there. It doesn't touch it, but it approaches it. And that's what that arrow tells us is approaches. Does it have symmetry? Let me show you how to do this algebraically. If I put in a negative for the x, what does a negative exponent do? Please somebody remember.
Wait, what did you say?
Not close.
You did a square root.
Turns it into a fraction. Turns it into a fraction. It flips it over and becomes positive. So does that look the same, completely opposite, or neither? Opposite as in sine opposite. Neither. It's neither. It's neither. All right, questions about the exponential function? I know this is boring. Y'all are looking at me like, what's wrong, Katie? I'm so sorry. It's not anything to solve. It's not anything to do, but you have to learn these so that you can start manipulating them and doing stuff with them. Okay, so watch this though. If I took out my calculator and I did y equals, and this is what Sally was saying, and I did second ln, so e to the x, right? I could do a zoom 6 and I could look at it. There's my graph. I need points on here, right? So if you do second graph, come on. I could pull some points off of there. Maybe -1, 0, and 1. That'll give me the points. And then the rest, you can kind of get on your own, if that helps some. Oh yeah, sure you can. You can. I could do y equals, I don't know if I'm in the right setting right now. Let me see. Sine X. I think I need to go to a... If you do a zoom trig, zoom 7 instead of 6, it should. Well, it didn't. That's okay. But still, you can see how it's still yeah, and it'll do all the same stuff for you. Any of them you can put in your calculator, yeah. Other questions? We got 3 more, y'all.
Before the test. I'm speaking 114.